Earth is the only place in our solar system where humans can live without a spacesuit, as far as we know. Therefore, is it possible to colonize other planets in the future, and if so, what are we waiting for? In this video, we'll look at planets in the solar system where life might be possible in the future, as well as how long we may survive on those planets. Hello, and welcome back to another fantastic and informative video. Thumbs up for the video. If you're new here, just subscribe to the channel, press the bell icon, and turn on all notifications to get much more amazing and incredible videos. Starting with Mercury. Mercury is our solar system's smallest planet, just somewhat bigger than Earth's moon. It is the nearest planet to the Sun at a distance of around 58 million kilometers. Mercury does rotate, but incredibly slow. On Mercury, one day lasts 59 Earth days and one day night cycle takes 176 Earth days. Mercury is a rocky planet, also known as a terrestrial planet. Mercury, like the Earth's moon, has a solid, cratered surface. It is difficult to survive on this planet as it has the most drastic temperature variations. On Mercury, no signs of life have been discovered. Temperatures in the daytime can exceed 430 degrees Celsius, 800 degrees Fahrenheit, while at night they can drop to minus 180 degrees Celsius, minus 290 degrees Fahrenheit. Its atmosphere is composed mostly of oxygen, O2, sodium, Na, hydrogen, H2, helium, He, and potassium, K. Mercury's exosphere is made up of atoms that are blasted off the surface by the solar wind and micrometeoroid impacts. As a result, we are unable to breathe in Mercury's atmosphere. Due to its intense temperature variations, Mercury is not likely a planet that humans would ever want to colonize. However, scientists recently discovered water ice at the poles of the planet, and another team found possible evidence for the chemicals, building blocks of life underneath Mercury's rocky surface. Mercury's neighbor, Venus, is the planet nearest to Earth, as well as the planet with the most equal size and mass to Earth. It is often referred to as Earth's sister planet. Most people believe Venus is uninhabitable since its surface temperature is about 900 degrees Fahrenheit, 480 degrees Celsius, which doesn't sound quite welcoming. Many scientists believe Venus was once submerged with water and had an atmosphere that may have supported life. Venus has an incredibly dense atmosphere completely composed of carbon dioxide and exerts a pressure that is about 100 times that of Earth. Since carbon dioxide is a greenhouse gas, which means it is very effective at trapping heat. Therefore, despite its distance from the Sun, Venus has the hottest surface temperature in the solar system. Venus also has clouds of sulfuric acid rather than water which strongly reflect the light from the Sun. We can't see the planet's atmosphere with telescopes, which is why Venus is so bright in the night sky, and often still apparent in the daytime. It's not exactly an easy place to visit or study, but that doesn't mean people haven't tried. However, the planet eats metal, melting and destroying spacecraft that have landed there within minutes. Just 2 of the attempts succeeded in taking direct pictures of the planet's surface. Recently, astronomers discovered a gas called phosphine in the planet's sulfuric acid clouds. As phosphine is formed by tiny microorganisms on Earth, it's conceivable that it's being produced by some tiny life forms, or it's some crazy new sort of chemistry we've never seen before. With the latest discovery of a possible sign of life on Venus, a new wave of missions to the cloudy planet could be launched in the future. A strong contender for a second home planet is Mars. Despite its flaming red color, Mars is not hot. Let's start by comparing the specifications of our 2 planets. Despite their apparent differences, the red planet and the blue planet have certain similarities. For example, due to their comparable rotation speeds, one day on Mars is just 44 minutes longer than one day on Earth. The axial tilt of Mars is therefore very close to that of Earth, at around 25 degrees, compared to our planet that is 23 degrees. This suggests the seasonal and temperature changes on Mars are close to those on Earth. Mountain ranges, canyons, and deserts can be seen on both rocky worlds, which have metallic cores and identical mineral compositions. However, The differences between the two planets are much greater than their similarities, with the Martian atmosphere being the most notable. The atmosphere on Mars, unlike on Earth, is very low, weighing just around 1% of Earth's air pressure and being unbreathable for humans. It's made up of around 96% CO2, 2% argon, and 2% nitrogen, with trace amounts of oxygen and water vapors. The thin air on Mars will leave you begging for air, and silicate particles will begin to fog your lungs. The low atmospheric pressure on Mars will cause your organs to burst in around 2 minutes, resulting in a quick but painful death. Mars is much colder than Earth, with average temperatures of -60 degrees Celsius, -153 in the winter, and 35 degrees Celsius in the summer on the equator. Mars is often very dry and sandy, with periodic sandstorms. The final problem is the shortage of liquid water on the surface of Mars. The poles of Mars do have water, but it's always frozen. The debate now is whether Mars is a safe place for humans to survive in the future. The short answer is no, not at first. There's no oxygen and it's very cold. But that's something we should work on, as carbon dioxide is causing global warming on Earth. This negative impact due to the greenhouse effect can be implemented on Mars to improve its climate and make it suitable for humans to live. There's a lot of carbon dioxide and water trapped in the polar ice caps, and blasting it up into the atmosphere with huge bombs wouldn't be difficult. Once it was spread uniformly across the planet, it would increase the temperature, allowing more carbon dioxide to be released from the atmosphere, resulting in a runaway effect that would heat the Earth very rapidly. Oceans would form as water vapors condensed and rained down. We might cultivate plants directly on the soil until it warmed up enough, and if the atmosphere were enough oxygenated, humans could be able to travel around the surface of Mars without a spacesuit or any other protective layers, much as we would on Earth. Unfortunately, this procedure, which is called terraforming, can take a long time. It is estimated that it may take several hundred or thousands of years to get everything ready for a picnic. Still, who knows, maybe one day we'll get it right and Mars will be the perfect holiday destination. Jupiter, at about 11 times the size of Earth and 317 times its mass, is the largest planet in our solar system. Jupiter has the shortest day of any planet, taking just about 10 hours to full a complete rotation. Jupiter, like the Sun, is mainly made up of hydrogen and helium. Pressure and temperature rise deep in the atmosphere, compressing hydrogen gas into a liquid. This gives Jupiter, the biggest ocean in the solar system, composed of hydrogen rather than water. There are hundreds of moons orbiting Jupiter. While Jupiter's atmosphere is unlikely to support life, the same is not true of some of its many moons. Europa is one of the most likely places in our solar system to discover life. There is evidence of a huge ocean underneath the ice surface, where life may be possible. So, it is possible to colonialize on Europa in the future. Neither Uranus nor Neptune shows any chance of life. The ice giants contain methane gas in their atmospheres, which gives them their blue hues, which will lead you to suffocate. The high temperatures on both worlds, along with the poisonous gas, would result in a near-instant death. When it comes to moons, Triton is Neptune's largest moon and the only place on the planet with any kind of stable land on which to create a colony. It shows signs of massive geothermal activity and a potential subsurface ocean made up of water and/or ammonia, which is why we'd like to move there. It's the coldest body in our solar system, but with both it and Neptune's combined energy, heating wouldn't be a problem. Ice giants like Uranus and Neptune and gas giants like Jupiter are difficult to colonize directly. Whereas Uranus' gravity allows for colonies suspended in the atmosphere, Jupiter's unforgiving atmosphere, staggering winds, and powerful gravity wells make that sort of approach impossible. These are the worlds that may be colonized in the future. I hope you find the video interesting. See you in upcoming interesting videos.